Hi everyone, welcome to the July DevOps Playground at our Global Logic office here in London this evening. Thank you so much for such a good turnout, everyone who's here. So after 3.5 years of working here, they've let me make my debut introducing the DevOps Playground. Finally, I've made it. So just a few housekeeping bits for everyone that's here today. So the fire, obviously the most important bit. If there is a fire, we've got an exit over here. We've also got an exit this way. You'll see us all walking towards, so just follow someone who works here. So you'll see there's a few guys in DevOps Playground t-shirts dotted about, and me as well. Obviously Sammy and Afroz who are down there. If you need the toilet during the talk, we've got some cards over there just to let yourself in and out, so it's just straight out the door where you came from. I'm sure you'll find your way. So I work here in our talent team. My name is Gemma, so we have to make a bit of a plug while we're here today. So we are recruiting across our UK offices. If you're interested in a career in digital product engineering, please come and talk to me at the end. We're looking for QA, DevOps, software engineers, data. If you want to talk anything data, these guys over here are you guys, so Sammy and Afroz. I'm more than happy to talk, but I will hand over to the experts today for an intro to MLOps. We hope you have a really good session and learn loads. So welcome up, Sammy and Afroz.
Cool. Sorry. Good evening, everyone. Is it definitely all right? Sounds like it might. Okay. Good evening, everyone. I'm Sammy. Nice to meet you. I lead the data science team at Global Logic UK and Ireland, which includes my colleague Afroz over here. 3 months ago, or 4 months ago, in the March DevOps Playground, we presented how to create your first data science model from scratch. A really, really simple model. It was quite a fundamental introduction to data science and what that means and why it's important to us. What you do as the next step is, once the model has been created, you need to put it in some environment where it can be put in front of people who are going to use the model. And there's many ways to do that, but it's not something that typically is done well. 80% of the projects that data scientists do usually don't end up in production. So that means that's sunk cost, that's effort, that even though theoretically it could make a big difference, and you could even show that it could make a difference, it's not in operationalized, it's not being part of the actual procedures. One of the reasons for that is the handover between data scientists and the people who actually run with things is quite painful at times. So embedding good principles and good software development principles and developer principles into the way that you actually run these things by using something like MLOps as a framework, and using MLOps frameworks that are actually written and available to run these models and get the pipeline and path to production much more efficient, substantially eases this process. So that's what we're talking about today. Afroz, actually briefly introduce yourself.
Yep, sure. Thank you, Sammy, for setting up the stage for me. So this is the first time when I'm, public talking. So please excuse if I misspell something or say something that's not meant to be said here. It's lovely to see all of you guys here today. And also, by the way, I work in Edinburgh office. So if at all there's a fire, I'll probably be following Gemma or Sammy. So please don't follow me. Yeah. So yeah, as you guys already know, I'm Afroz. I work as a data scientist here with Global Logic. I've been a part of ECS and now Global Logic for around 7 years. And during the 7 years, I've worked with multiple clients. Like Gemma already said, we do work in very challenging environments, and there's a lot of skill sets that you get to learn. And I think probably I'm the best example because I've worked in a spectrum of skill sets. I've been in testing and then developing automation frameworks. After that, it was about Amazon Connect, then data science, and now it's MLOps. And yeah, so during this tenure, I've also worked with a lot of AWS services, including code pipeline, step functions, almost name every service. And I must have done something there probably, but got very less chance to deep dive into most of it. But with MLOps, I've been doing that for quite a long time. We were also amongst the first one to test out SageMaker Studio with AWS. And yeah, so that's where I began my journey with MLOps, and it was almost 2-3 years back. Yeah.
And briefly to add to that, Afroz is a rare example of somebody who's a data scientist who is interested in MLOps. We have data scientists who know what MLOps is and know how to use it, but usually do not want to actually do it as their first thing. So we very much appreciate him being initiative on our front over here.
All right, so yeah, what are we talking about today? Let's just discuss on the topics that we are talking about today. Firstly, obviously, this is what we are here for. What is MLOps? We'll be talking about, we'll be diving deep into this topic and understanding it in a better way. The term has been fiddling around for a very long time now, but there are some myths we'll be busting and also learning more about what exactly it is. Then we'll dive into who are the people of MLOps. It's not just that one person takes care of the complete DevOps lifecycle, and similarly, it's the same case with MLOps. It's not one person. There are many personas involved here, and there are many responsibilities that they take care of. Yeah, so this will be the most interesting part. We'll be implementing our first MLOps pipeline from scratch. And again, we'll be using the DevOps infrastructure more or less. That's the reason we are here today with DevOps Playground. We'll then discuss about the tools that are available for MLOps in the market, what kind of platform do we need to choose for, what kind of platform we need to go for when we want to deploy a machine learning model. And lastly, we'll discuss about why exactly do we need MLOps, and is there at all a need? We'll come at that question. We'll try to answer it.
The answer is yes. Very
Right.
briefly, also just to add, we're focusing on AWS today because we know AWS quite well, we're an AWS partner, but there are tools across all of the major cloud platforms and indeed the ones that are not so major, and there are many open source alternatives as well. So take everything that you see here today as an example of what you can do with this, and we're quite expert at this, and this is the framework that we've used or based our approach that was recently being published in a big four bank in the UK. We run, I think, 500 data scientists using that platform, and it's substantially improved their workflow. So that's what we'll be focusing on today, but there's many alternatives to this.
So before we begin with the overview on MLOps, I just want to know how many people have heard of this term or are already working on MLOps.
Okay.
Okay, that's okay. I mean, right. So it was a good decision to start with the overview on MLOps, I suppose. So I'll just start with an analogy. Let's say many of us, I mean, obviously we at some point have researched on what type of car we need to buy. And with that, we kind of put our efforts in trying to find the perfect car that would fit for our purpose, right? Let's say, do we want to buy a car that is for city or a sports car, or we check on the horsepowers for it, we check on the color, and obviously we do check on the budget as well. But what if I say that you should not drive the car and you just need to keep it parked in the garage? That would be really ridiculous, right? Why are we buying the car? But that's the case with machine learning models. It's you spend a lot of time, you spend a lot of resources, efforts, and obviously a lot of money on training and creating your machine learning models, only to realize that they would never be used. And that's probably because you face some operational challenges, some technical challenges, or maybe due to the fact that the model doesn't comply with laws and regulations, or maybe just because there are heavy investments involved in trying to make the configurations to the machine learning model in order to productionize it, right?
It would be nice if this was baked into the original ideation phase of the project, but rarely is that the case. And we won't usually show up to a client that has a good MLOps platform and framework available from day one. We may need to show the model is viable before we actually transition into that, and then there has to be some sort of transition there. At the end, at some point, it's going to be handed over to people who aren't data scientists, while we recommend data science involvement at all stages. Part of this process is making sure that people who know nothing about data science can still work with these models and trust them. And that can be from data savvy people all the way to people who know nothing about data. They need to know that they can trust what's in front of them. And that's also part of this as well.
So exactly, in order to overcome all these problems, this is where MLOps completely fits in, right? And as we can see, the term itself combines machine learning and operations. What could be better name for handling the problems related to machine learning? And so going by the definition, MLOps is about standardizing and streamlining the machine learning lifecycle management, right? So obviously, when we are dealing with some terms, it happens with DevOps or even with software engineering or even with roles, there are some myths involved with it. And the first myth that we are busting today is about machine learning models and about, again, MLOps. So MLOps is not just about deploying the models. When it comes to machine learning, we often do a mistake of thinking that model is the end product of the entire project. That's not really the case. With machine learning lifecycle, we are dealing with obviously the model, but we are dealing with data, and with it comes different steps about data collection, data pre-processing, data gathering, data transformation rules. Then comes model, where you have to find your candidate models. Experimentation phase. Then comes the part about monitoring. Obviously, you can't just keep your models running. You have to keep monitoring it for checking the performance of it. Then about machine learning infrastructure. And MLOps, what it does is it kind of brings everything together, it starts from model to coming to systems, and then it kind of combines all the processes together and makes it work in a streamlined way. That's what the definition says.
Yeah, just very briefly, as an example of, you could think you've done everything right, the model might be accurate, and everything be perfect, and then the data that underlies the model changes. And an example of that is the airline's pricing model. Completely failed during COVID-19 because there were people who were buying tickets, but very few of them legally could buy a ticket, and so they kept dropping the price because no one else was buying tickets. That is covered by this. If you have data drift detection and things like that as part of your built-in, but that's very far away from creating the original model, where you look at a data set which doesn't have this problem. And that's an example of what Afroz was talking about. Even if you go into the other extreme, which is obviously the data could be problematic, or the model might crash, or the instance might not be big enough for the predictions, or too big for the amount of predictions that's being used, or no one might be using it, the model rather. But yeah, that's absolutely part of this as well.
Yeah, and just on the back of that, many people could think that what if we give the models directly to the production team and they deploy it for us, without even having the grasp of what the model is doing or what kind of business goals it's trying to solve there. So how many of you have, yeah, how many of you have tried to actually weigh yourself on different weighing scales and got the same result out of all the weighing scales? I bet no one, because I tried multiple times and I couldn't get one.
Or the same weighing scale on different days.
Yes.
Yeah.
And yeah, the same weighing scale, even after 2 seconds, if you do it, it'll be different. And I usually prefer if it says, whichever machine says the lesser weight. Yeah. So that is because these weighing scales, they are designed on the parameters of measuring the pressure on the springs, and not the real parameters that a human weight should be calculated on. That's probably body density, height of a human, or maybe even, of course, fats, right? And that's exactly with machine learning models. When it comes to deploying a machine learning model, you need to understand the crux of that model. You need to understand what are the parameters that were taken care of when you were training the model. And what do you need to look at when you are actually productionizing the model in order to monitor its performance.
Yeah.
Right.
You might even accept a lower accuracy as long as it's relative. So even if the scale was 10 kilograms underneath the real weight, if you saw that it was going down, you would know that you're on the right track if you wanted to lose weight. That's still possible. Yeah.
So exactly, to address these problems and to prevent any inaccurate models or inappropriate models, I would say, after what we have seen with Microsoft chatbot.
Yeah. Or detection of the failure of darker-skinned facial recognition systems in the US. For African American women, it was 66% accurate at detecting is it a specific person. You can imagine that's a pretty high failure rate for this person committed a crime, we should arrest them. It was 98% accurate for white men, and that's what it was in the data set. So there's things like that, which also can be addressed with this as well.
Yeah.
Let alone if the model is biased, that can be a different thing as well.
So exactly, you need to understand and grasp the crux of the model in order to deploy it to production. So there needs to be someone who gets what they are doing, and not just a production team who can make decisions on infrastructure or on the software engineering side, on the design pattern side. Right. So let's look at this pie chart. I prefer pie charts, by the way. It's very easy to understand and it looks colorful. So anyway, this is one of the metrics that Algorithmia has been keeping a track of, and it was in the effort to gauge how long it takes for an organization to deploy a machine learning model. And as we can see, almost half of the organizations, they take almost 8 to 90 days to get their models into production. And not just that, 18% of the models, as we can see, it takes from more than 90 days, and some even take more than a year, and some of them are not even sure on how long it takes.
Just to reiterate on this as well, that's deployment. The model's been made, data's been sourced, data's been found, stakeholders been talked to, the use cases been made. That itself might take a very long time, could also take a year. So another year on top of that, that's problematic.
Yeah. And on the top of this, last few years, we have seen that there has been greater focus on using machine learning for getting business benefits out of it. But it so happens that businesses just try to think of getting a machine learning model. They don't think about productionizing it, or rather when they come to a point of thinking about productionizing it, it's too late in the life cycle. And again, by looking at the metric that Gartner has shared, it says that by 2024, 75% of enterprises will shift to operationalizing AI or machine learning. So we don't know how long they are going to take to actually deploy it to production.
Yeah, and
right?
operationalization, in our definition, it goes one step further than productionizing, which is that the model is available, ready, resilient, and everything else. If the business isn't using it, it doesn't make a difference to that business. So making sure it's built into the procedures, that people trust it, but also that it is actually embedded into the software procedures. Example would be medical AI. You could have something that's 100% accurate, and if no patients believe it and no doctors trust it, it will never be used. It's still a failure, even if you have something that is productionized and the MLOps pipeline is perfect. So that also needs to be factored into this as well. Who's going to maintain the system? Who's going to trust that it works? Those sorts of aspects.
Yeah,
please.
Is there any data on redeploying?
When you say redeploying, do you mean making another model or retraining a version of the model?
Right, because what you've got up there, I don't know whether it's actually, are they redeploying every 0 to 7 days, or are they just deploying a model? It takes 7 days to come up with that model, they stick it on the system, and then leave it for 6 months.
No, this metric was specifically about the organization trying to deploy the model from scratch. So not about redeploying the models. I think probably there was a metric, I remember reading about it. Probably after the session I can share you the link for it.
Well, to add to that, you're right to say, I suppose that you were asking, it's probably going to take less time for a version of a model to be redeployed. How often you should redeploy models is another separate question there. So once you made a decision to say there's a second version of the model which performs better, let's get that model into production. It's not as simple as just deployment. You would need to check that we think it's better, let's check it really is better. So you might use what's called a blue-green deployment, where you have both models live and 5% of the data is fed to the new model, customers is fed to the new model, 95% to the old model, to check that the performance really is better. If you're expecting something like, if you have a metric like let's say YouTube's watch time, how much people are spending watching videos, and you want to increase that amount of time per video. With model B, it's like 10 minutes longer than model A. Great, fantastic, so let's roll it out to all the customers. And the ability to roll back as well is very important as well. So theoretically, it's going to be very short, but the separate questions about how long should it take before you deploy a new version of your model, it may still take 7 days, even though you could do it in 10 seconds.
Yeah, that's probably it. And to just give an example, I've been working for a financial services institution. I'm not supposed to name them, but if you get it, it's fine with me. Don't just say it out loud. So earlier it took them...
They've been public about somebody developing their MLOps platform. We developed it, so...
Yeah, that's the clue. So earlier it took them about months to get their machine learning model into production, and that's obviously a very, very long time taking into consideration it's a financial services institution. But later they started thinking about machine learning pipelines, started thinking about applying the MLOps principles to it. And it took from months to a few weeks, and now the process has been so streamlined that it hardly takes over an hour or maximum 2 hours to get their model into production. And that's the benefit that we can get out of an MLOps pipeline, or streamlining the complete workflow for it.
There's a secondary benefit as well. We'll come on to it on the people MLOps slide, but it's important to mention. If you can get your data scientists, or the people who are creating these models, who may even not be data scientists anymore, I have some reservations about that, but okay. If you get those people bought into this as well, you shorten the deployment for them as well. So one of the things for the same bank that we did was help them spin up environments to do exploratory data analysis and other data science frameworks within this ecosystem, rather than having some people on their laptop doing things locally, and then you have to work out how to get that into this in the first place. So that also shortens the life cycle as well, and it helps everyone, because if a data scientist quits and then the laptop is formatted, you didn't lose the model, things like that. That does happen in banks.
So clearly, I mean, it saves a lot of time. It has benefits to it, having a properly streamlined machine learning lifecycle, having MLOps implemented. So what exactly is the problem? Why aren't all the organizations doing it? And what are the challenges that they are dealing with? We'll have a look at it. If you remember, just from 10 days ago, I had defined MLOps pipeline.
You've been here for 10 days, right? We've been talking for 10 days.
Oh my God, it's not that boring, come on. It was just 10 minutes ago that I had defined MLOps, being a standardizing and streamlining of machine learning lifecycle management. But if you see at this cycle, it looks pretty straightforward. So what exactly are the challenges? I'll try to explain that in two different stages that we usually see in machine learning. First is the experimentation phase. Here we try to answer questions about, can we use this data to solve the business problem? Whatever data we have, is it enough to solve the business problem that we have at hand? And what model would be the best fit considering the business problem and considering the data that we have at hand? So in this phase, usually we face challenges with data analysis and data preparation where we need to keep a track of versions of the data. So whatever data we are getting in raw format, we have to do some transformations on it, and then probably feed that data in to a data scientist, let's say, where he'll be doing his model training and trying to find out the candidate models for it. But these versions of data and the transformation rule, it needs to be kept a track of. Otherwise, you're just repeating the process or having manual steps under it. And with that, we also have problems about different ML models. So like I just said, data scientist trains different models, tries to find out what would be the best fit for it. Is it a clustering problem? It's a regression problem? Or do we need to apply a neural network to it? And all these models, we need to maintain versions of this model so that we can go back and check on which was the best fit for it and try more steps about testing the model, validating the model. And with that comes the parameters that we are using in order to train all these models. So there are a lot of things that we need to keep a track of, and that's probably one of the challenges that an organization would face when they are trying to streamline their pipelines.
It can be hard in the very initial stages of a data-driven journey for a company to justify doing all of this, because if you have nothing and you pick the lowest hanging fruit use case, and you can do that use case very quickly, and then you can get into production very easily with one click or whatever, that's fine. It's when you have a team of tens to hundreds of people who aren't data scientists trying to consume this and have a resilient output, and making it so that when you're picking slightly less lower hanging fruit, you can start to work out, okay, well, this model performs okay, but when we train it again, it performs better or worse. We'll use different approaches, it might become more important. The sorts of use cases I play about early stages of my career, any approach would have worked, because the pattern was so obvious. You just needed something that could be made objectively rather than just somebody saying, yep, no, that's what the alternative was at the time for some of those clients. Those things make this a lot more important as well. And there are platforms available that make it okay from day one, but you still need to sell this on your data scientists as well, because they need to understand why this benefits them. And ultimately, it's the pain, avoiding the pain months later, when somebody's like, that model you made 5 months ago, do you remember what you did? And where's the code? And where's the data analysis and data engineering? And all that?
Right. So after we get the answer for our candidate models and the data transformation steps that we are using, and about answering the question that is the data enough and is the data right for the business problem that we have at hand, then we move to the phase about productionizing it. And with productionizing, the challenges just keeps on growing. We have all the challenges that we had in experimentation phase with respect to data. But with model, it evolves into having the model version that the candidate model that we have chosen. Again, that even has versions to it, because that's not the only model that we train. It could be that we use different parameters in order to train the same algorithm that we had. And again, we need to keep a track of all those parameters to try out what would be best for production. And again, when we have got the trained model, it's not just again about the model, but about the inference steps. By inference, what I mean is getting the predictions out of that model. So there are a few steps that you need to follow in order to get the predictions. You can't just feed the data directly to the model and get the benefits out of it. It needs to go through some kind of data pre-processing. and then reach the model so that it'll understand, okay, this is what he's trying to gauge from it, and then give the answer for it.
Yeah.
So you need to keep a track of the testing data set, model versions, inference steps, everything that is mentioned there. But also, one more step to productionizing it is about monitoring. So when your model is already live, you need to keep a track of how the model is performing. Are the results actually appropriate? Are the results actually compatible with what we were seeing in our experimentation phase or in the testing phase? Or is the data that we are getting in production completely different from what our models were trained on? So you need to keep a track of everything, keep an audit trail of when the model went wrong, if it did. If not, what could be changed in order to make it better.
Yeah, and you have all the fun of the stuff we talked about a moment ago, and now the business depends on it and it matters, and the return on investment has been articulated, so they're going to care a lot more if it goes wrong. That's why this stuff becomes a lot more difficult as well.
So we again come back to the same question, what is MLOps exactly? So it is about applying DevOps practices to data science and machine learning pipelines, let's say. And here, like you can see, we have 3 different things to handle: a model, operations, and the data. But again, it's not as simple as it looks there. With model, it's about maintaining the code for your algorithms, maintaining the code for deriving the predictions out of it. With data, it scales from data collection, data gathering, to data pre-processing, having the data transformation rules. And with operations, obviously, continuous integration, continuous delivery, setting up the infrastructure for machine learning pipelines. So that's all that you need to think about when it comes to MLOps, or exactly that is what MLOps is about. Having a way to handle all these 3 things and bring it together into one streamlined way of configuring it, let's say. But we can define MLOps as just a behavior, like we do with DevOps. It is a behavior, and like we have developed DevOps engineers. We have software engineers who kind of follow the DevOps practices in developing the application. And similarly, with machine learning engineers, we would want that a machine learning engineer should follow MLOps best practices when they are trying to build ML systems. And those practices, it includes everything like whatever I've described about the model, about the data, and about the operations. So essentially, MLOps aims to facilitate the creation of machine learning life cycles in a way that it follows the principles of continuous integration, continuous delivery, infrastructure management, monitoring, having an audit trail, having a way to have a data pipeline, your model pipeline, and million more things that we can keep a list of, and it will go for 2 hours probably when we try to list all those things. Yeah. So. And obviously, we have been fiddling around with the term DevOps. Again, it relates to DevOps. I already said that it's about deriving the principles of DevOps. So how does MLOps relate to DevOps is the question. So we could say that MLOps is about applying DevOps ideas to machine learning, but that would be a very condensed way of describing MLOps. It's not just about following the DevOps principle, but expanding it to include machine learning models, to include the data, to include everything that happens with data engineering, setting up the data pipelines, to getting the model into production. And just to list a few differences about how MLOps differs from DevOps. So in DevOps, what we usually have is a software which on executing you get an executable or an artifact, which again you test, and it goes through different iterations until you find a not bug free, but at least something that you can deploy into production. So that's the output that you get in the DevOps way of working. Whereas in MLOps, here we have both code and machine learning algorithms and data. And you combine this to create or to train your machine learning models, which is a serialized file, to which you again pass data and get the extract out of it. So that's the major difference that you'll see between DevOps and MLOps. But again, with DevOps, all you need to do is maintain the version of code, maintain the version of your code pipeline. But with MLOps, you need to maintain versions of model with hyperparameters, data transformation steps. Obviously, with even the DevOps side of it, maintaining the pipeline code, maintaining everything about infrastructure management to it. So that's the way MLOps deals with it. You know, takes the principles, takes the crux of core of DevOps, and tries to, wrap it around the complete machine learning lifecycle. So there are many ways of explaining a machine learning lifecycle, but here we have tried to explain it in a way of having a correlation between who are the people of DevOps, MLOps. That's a bit confusing. Who are the people of MLOps, and what are the roles that they carry out throughout the machine learning lifecycle? So it starts with like it does in every software development project, with the business analyst trying to analyze the business problems. That's not there. I've just tried to describe the ML lifecycle there. So it starts with a business analyst trying to gauge the problem and trying to find that whether this problem is solved by a machine learning, or is it just another software engineering problem where you will apply all the if conditions to it, and that should be it. That should solve the problem. So after we analyze that, no, this is a machine learning problem, we have data engineers and data scientists who kind of try to find what kind of data you'll need in order to solve this business problem that we have at hand, and what are the data sources that we need to gather the data from. And that's where it starts from a data engineer trying to define the data transformation rules, data cleaning steps. We can't just input the raw data and start building models out of it. There needs to be a data pipeline. The output that we need to get from data engineer is a data pipeline, which is in a way that you just plug in the raw data, and it should do all the cleaning steps, data transformation steps, and give us the data in a usable format that could then be fed into the experimentation phase. And this phase is mostly carried out by data scientists, where they analyze the data once they have it in a proper usable format, and they do some data preparation and validation phase. By that I mean is they then split the data into training, validation, and testing, which can be then fed into the models. You do your model training using the training data. You do your validations using the validation data.
That's like your real-world test. See, okay, I'll keep 10% of the data aside, and I'll see if the model would work on that 10%, because it's seen that 90% during its training phase. It might have learned patterns that you're trying to avoid. So that's ultimately your real-world test until you actually deploy it in the real world, where you do your real-world test.
Right. And with that, I mean, when the data scientist is analyzing this data and doing the data preparation and validation, there could be a point that he realizes there are some more steps to be added to the previous phase of cleaning the data. So they feed that back. So every pipeline here needs to have a feedback loop into the previous pipeline to say that how we can streamline it better. So it's not that first it took months and directly it will start taking 2 hours to deploy a model. Yep. It's an improvement process that you need to go through. And from this experimentation phase, we hope to get the final product as the models, candidate models, and also a proper streamlined data pipeline, let's say, which is again then taken by an ML engineer who, with the help of software engineer, tries to build design patterns on how this could go into production. It's not that you get the model and you just deploy the same code into production. It could be possible that when you got the data, let's take an example of the housing model, let's say. So it is possible that when you got this data, it was a flat data structure. You had your zip code, you had your area related information, and you had some more information about the names of those areas. But in production, you probably would get only zip code, because this data is stored in some other database. So you need to plug into that database as well. So your steps or your code needs to be in a way that can pull data from all these sources, do the steps, and then feed it back to your production model. And that's what ML engineer or a software engineering team does. It has an automated workflow pipeline design which can take care of all these things, take care of the machine learning models and testing of those models, to then have a final model which could then be registered in the model registry. And model registry, you can think of it as a database for your machine learning models, which has information not just about the models, but about the parameters that we used in order to train those models. And then comes the DevOps part. Rather, the DevOps part is actually in every phase you can see while creating the data pipeline, experimentation pipeline, even the workflow pipelines, and obviously about deployment and monitoring things. Here even IT is involved when you're trying to analyze how you need to gauge the performance and what parameters you need to look for there. So to give more information about these people and about the personas, I'd like Sammy to give some more details about it now. Yeah.
Sure, please do. So we've gone over the detail of what MLOps is. We've already gone through quite a lot of the benefits here. This slide articulates the people who are most likely going to consume or benefit from or contribute to the MLOps frameworks and pipelines that would result from this and why it's important to them. I'll start from the left. So for the business analyst, I did allude to this at the beginning, but they need to trust what's in front of them and they need to be able to see the output of the model. So they benefit from a pipeline that serves them the most current model. They benefit from a pipeline they know they can trust, that is not just going to return. I'll give you an example. There was, at my previous company, they had a huge problem with people, really, really bad credit rating people on their database, on their system. That meant that they had they're hemorrhaging a huge amount of money per year. And the reason this happened was somebody noticed that when the model couldn't make a prediction, it would give a good score for whether they should take on the system or not. And it was an energy company, and so these energy brokers, two of them in particular, decided, oh, we'll deliberately misspell the names, and then we'll get huge amounts of profits and things. And then obviously a few years later, they find something a bit wrong with the finances. So that's about the trust, right? And ultimately, you couldn't trust the output of that model. But the model works when you put the person's name in correctly. So that's important. Ultimately, the business analyst or whoever the consumer of the model is needs to use it and needs to be operationalized. So that's what this end goal is, right? What are we doing this for? Are they actually going to use it? Is it useful? That's also part of this as well. And so they will hopefully get this out of the system. So tying this into this framework in the long run will lead to shorter cadences between there's a new model, it's been tested, it's working well, we've done our blue-green deployment, and it works. Here you go. And using a holistic framework like the AWS ecosystem, you could use QuickSight as the thing that business analysts use. You could deploy a model using SageMaker directly into this and have all of those benefits. We talked about the data engineer. The data scientist in their first phases may produce data transforms that need to be done at scale, much, much larger scales in production, because the data scientist might take a small subset of the data available to do the initial experimentation. And so they need to make sure that the steps listed here are productionizable and repeatable, and you can check that they would work every time. You could have a column which is numerical but as a string, so it might be typed in characters, and the model might be expecting a number from a number rather than a string. That sort of stuff is important. That's the data cleaning part, and making sure that this data pipeline is resilient to these sorts of things. I am expecting this column to be 50% missing values. If it's 100% missing values, what's going on? That's the important part here. By the way, these models generally don't like missing values, don't like changes in categories, increases or decreases in the number of columns. You need to be able to handle these things. Data engineers have good systems to do that, but putting it as part of the MLOps framework means that the data scientists can rely on that stuff already being done for them. It's a pain to do this as a data scientist because we've worked on raw data and it's not ideal. We've talked about data science. I'm more than happy to go into more detail another time, but obviously the data scientist benefits from the fact that the data coming in is more streamlined and smooth, and you can rely on being able to access more different data sets and not being given one day before you're due to hand over the project a new data set that you have to process, which has happened before. You can rely that model building is a bit easier, and you know that the model you produce can be productionizable, because that is the first question our client would ask. Great, you could save 100 million a year. Now what? You could say, yeah, well, you need an MLOps framework, but if you already knew there already was one that you could tap into, or you had plans on how to do that, or you used a model that was compatible with that, something as simple as Dockerizing your model putting it into a containerized system. This is the DevOps principle. And I'm sure that there was one on Docker very recently. I'm pretty sure there was a DevOps playground on Docker. Doing that would mean that, okay, this will run, and we can put it on these in this ecosystem much more easily, rather than, it runs on my laptop, but I'll point this at the internet somehow. So that's not ideal. The assistant ML pipeline is crucial as well, but yeah, it's very much on what it needs to do as opposed to how it needs to do it, because the ML engineer, that's basically their entire job. So ML engineers, they will want to inherit code that is productionizable. So if it has been built in a framework that encourages this or facilitates it, like SageMaker, that's going to help them substantially. And the model monitoring becomes very crucial for this. So you can build your own metrics, or you can rely on the metrics that are already there. Something as simple as the size of the box you need to point your the predictions from the inference endpoint. If it's too small, your memory usage might be very high, and your endpoint might crash, and then you may not make a prediction in time. So the monitoring could be this, or it could be timeouts on trying to make a prediction, because ultimately you might serve this using an HTTP or HTTPS endpoint, and when you don't get a response back, there's a problem there. So it's constantly making these responses. It's putting in a known value to try and get a known result. That's the sort of stuff that could be done there. Software engineers, of course, they want code. They don't want what we produce, which can be code and can be written well, but is generally written more experimentally. So tidying up that code and making it actually testable. I had somebody who said, the code, when you write a test for machine learning models, the test is, does it produce an output? And I could not understand why you were saying that. It's like, what if it makes the wrong outcome? It passed the test, but it's terrible. So putting actual tests like, is the accuracy on this known data set the same as it was yesterday? Is the percentage of missing values in the column, as I mentioned earlier, is that a known percentage? So is the data staying roughly the same? Is the model performance and accuracy staying roughly the same? And ideally, there'd be a feedback loop. I mean, there are frameworks to do this. I think I mentioned augmented AI in one of the past playgrounds, but sending some of your data to a person to check what they would say. So if you've got a panel of experts, are they reporting the same values on the same data points as your model is reporting, and continuing to check that that's okay and working? And then, of course, then the DevOps itself. So making this actually something that when you have a new version of the model, it's not just sitting there and waiting for someone to drag it into an AWS instance or something, that it will actually deploy into a thing. And we can check if that's successfully or failed to deploy. We can check things like serving into different regions, so that if you have a model for US customers, it's in the US, not in the UK, so that the response time is quicker. And fundamentally, yeah, scalability and performance. These can cost a lot of money to run. So if you make the code really performant, and if you make the code reliable, and you make it better, and you use the serverless frameworks if you want to use those, or you use scalability or scaling groups and things like that, you can apply principles that make it more resilient and cheaper to run. The worst thing that you can do as a data scientist, and so the easiest thing to do, is just deploy your model onto a SageMaker inference endpoint and leave it, because it's constantly costing you money every hour, and no one might use it, and it doesn't tell you if no one's using it. So applying something that says, okay, no one is using this, let's put it into a cold shutdown phase or something, or serverless, but that makes it more difficult. So yeah, many different consumers here, more than is on this system here, but using a framework that encompasses all of what these people are trying to do makes everyone's handovers and lives a bit easier. But equally, you can see that there's 6 different categories of people on here. It's easy to say, oh, but you only need one data scientist to do all of this. It's not going to work out so well in the long term.
Yeah. So now we'll be going on the interesting part. So what we'll do is each one of you will have an EC2 instance where you can play around and launch the resources that are required to create a MLOps pipeline. And also we'll have one user each for AWS instances that you can access. So before that, let me just give an overview on what we are doing today. So we'll be using code commit. We already have the code deployed there for data pre-processing, for modeling, and for testing as well, even for getting the predictions out of it. So all the code resides there. We'll be creating resources using a CloudFormation template, which you'll be using your EC2 instance to deploy. And then we'll have building the code pipeline from scratch. It won't be using a CloudFormation template. We could do that, but this will be building the code pipeline from scratch using the AWS console. And the steps involved there will be first to check the source of both data and for your code. So you need a trigger to actually keep your pipeline running in order to have it in an automated way. So if at all there's any changes in your machine learning algorithm, or there are changes in the data collection, pre-processing steps, the pipeline will be automatically triggered, and it will take you through different phases of testing and deploying the endpoints on QA instance, and then asking for a manual approval after you have tested your system, and then deploying it to production environment. Then we'll have the lambdas deployed to launch and monitor both your ETL jobs, that is data pre-processing job, and your training jobs. After that, we'll have a step to perform the system test, and for this we'll deploy step functions, which will evaluate your development model, or rather even you can call it a QA model. And for that, we'll have a threshold set, which will look at the mean squared error of the machine learning model. And if the model threshold falls below the threshold that we have set, then it will move to the next stage of deploying the model into production environment.
So that's like a sanity check to make sure if you have a 0% accurate model, it's not going to immediately go to production, because if you let it all run, it would do that.
So this is the kind of architecture that we'll be looking at today, where the people of MLOps, they'll look at the part of code change or do the data updates or the code updates as well, which will trigger our code pipeline. The first step here will be building an image. So here we'll be using build your own container scenario. So we'll build the image for training our code and for getting the predictions out of it, and also for deploying our CloudFormation templates for deploying our endpoint, SageMaker endpoint for both development and production, and for deploying the step functions. Then we'll move to the next step of launching the ETL job, which will be AWS Glue job, which will do the data pre-processing part.
In case anyone's not aware, extract, transform, load. So that's basically data engineering.
Yeah. And we'll have a CloudWatch event monitoring the Glue job, which will feed the status of the Glue job back into the pipeline. If at all the Glue job is successful, we'll move to the next step of model training, where we'll have another Lambda function to launch SageMaker training job. We'll have another CloudWatch event monitoring the training job and feed the information about the progress of that job back into the pipeline. After we have the status successful for our training job, we'll then deploy a SageMaker endpoint, which will be our development or QA endpoint, which will be tested in the next step of system test using the step functions. And within the step functions, there's one more part which I'll go through later. Once we have built the complete code pipeline, I'll go through different steps that are involved in the step functions. After we have the system test successful results, the model is below threshold, it will deploy another CloudFormation template, will deploy your SageMaker endpoint for production, and will have auto scaling on the SageMaker endpoint. And also will have data capture enablement on the SageMaker endpoint. So with this data capture, we can see what data is coming into the model from production, so that we can then build a feedback loop in order to train our model on the production data, or it will be useful for us to let us know that where our model is going wrong exactly, and that will be the end of the code pipeline there. Okay, so I hope everyone has their laptops ready.
Are there any questions, by the way? And at any point, if you've got any questions, please feel free to ask anything.
Any questions? No? Okay, so.
Please, no.
How long does it take generally to create a code pipeline that would do all the things you needed to do?
Sure. I just remembered I was supposed to repeat every question. I didn't do that earlier. How long does it take to make a code pipeline?
Okay, so it will completely depend on the machine learning model that you have at hand. If it's a NLP problem, natural language processing problem, then the steps will be different in order to have your data pre-processing. If it's a computer vision problem, again, the steps will be different and more complex, because you need to pixelate your images and have different transformation rules applied there, so that it could be fed into the model. But yeah, there's no definitive answer to how long it will take. It completely depends on the skill sets that you have, and also the machine learning model that you're dealing with.
Hmm.
Yeah.
Any other questions? Okay.
So you can go to this site there, lab.devopsplayground.org, and you need to enter your meetup username. So let's say Sami Al-Sindhi is your meetup username. So you need to enter that, taking into consider the case sensitive nature of it. So S capital, and then Sami, and then space, and then Al-Sindhi, A capital to it.
MLOps, right? I see.
Yeah. Okay, so the next stage will be to go to the IDE.
If anyone uses AWS, you may want to use an incognito browser because this will just keep an environment separate.
Are all the usernames variants of pandas by any chance?
I'm not sure. It would sound like something we would do. So
I've got a panda. So.
Yes.
they're different kinds of pandas. That's why I'm reliably informed.
So if you've got like a moody panda,
Yeah.
it's not personal.
That's what he says. That's what he says.
Okay, so you have your
We'll zoom in a bit, maybe. When you get a chance.
Changed it for you.
Yeah, I'm using the changed one actually. Okay. That's some problem with my username. So once you have this, both the IDE open and the terminal open, you can go through the code that we have there. Right. So before diving into that, and until Patrick solves the username problem for me, I'll take you through the actual code that we have in code commit. So let's go step by step. This is the ETL branch that we have in our MLOps repository, which contains the code for data pre-processing. If you want to read more about it or get more details, obviously you can go through the code. I'll explain it in a bit though. So in data pre-processing for this, right now we are dealing with a bank marketing use case, and here we have the data related to obviously the bank marketing on trying to predict who are the specific targets that these advertisements needs to go through, because the banks, they have a tendency to give call to every single person even though they are not interested. So it's about trying to identify which people would be interested in getting the offers and trying to target their marketing just to limit it to those people there.
This is a free data set that's been like approved for use, so it's a public data set.
Yeah. And the first step that we'll do is normalize the data there. With normalizing, what I mean is renaming the column names, because we need it in a specific format when it goes through a processing job that's running on Spark. And also to normalize the data in terms of feeding it to machine learning. So let's say we have a column named job and it has different job roles attached to it, like admin or consultant or something. So it will create a column with respect to each job, that is job underscore admin, and it will have just Boolean values there, 0 and 1 under it.
Yep.
So this is called as getting the dummies function for it. There's a pandas function, get dummies, which does this for you.
Use caps lock. Caps lock.
All caps, okay.
Sorry, can't do this.
No problem.
And just to mention there, an example of where this is different to what the code a data scientist would write in a Jupyter Notebook interface, which is sort of a skinned version of Python. Normally, you would not write things like this in terms of functions initially. You would make it into functions towards the end. But you need something that will take one input and process it irrespective if that changes in some way, and then return an output that is defined. So example, what if there's all the job names change? What if there's a new job name? What if a job name is renamed in some sense? It needs to be able to handle those sorts of things. If you just took the job range that was in that database, and then the new job comes along, like say MLOps engineer, and your database doesn't know what to do with that, then the model might fail, or it might just be very inaccurate. You don't want either of those scenarios.
So after we have normalized the data, we'll then split that data into different sets that we need in order to train our machine learning model, validate it, and then go through a testing phase. And we have used a ratio of 80% training data out of the whole data set that we have. The remaining 19% of the data will be used for validation purpose, and 1% will be used for testing purpose. That will be used in our system test stage. Yeah. So that's about ETL branch. We also have a few more code relying there. It's about launching the glue job and what are the configurations required in order to launch that AWS glue job. Then comes the part about model training. And in model.py, we have the code in order to train our model, what's the algorithm that we are using. And before even going through the algorithm, like I said earlier, it needs to go through some data processing again to check on. So when we are reading the CSV file, it needs to add column names to that to the actual rows that we have there. So here we'll be using a deep neural network TensorFlow algorithm. I won't go in the details of it. We are here just to look at the MLOps pipeline and to look at from a perspective of a DevOps engineer or an MLOps engineer. So model.py, it is all about getting the predictions and also about model training. Then we have assets which will define the configurations for deploying our development endpoint and the production endpoint, and for launching the SageMaker training jobs.
SageMaker is AWS's sort of machine learning and data science framework. It encompasses many things, but it has the sort of serving infrastructure as well as some example models that you can use that are pretty powerful, actually. We're not using those aspects today, but we are using the serving infrastructure.
Yeah, and like I said earlier, we'll be using bring your own container scenario. So this is the Docker file image that we'll be deploying in our first step. And again, build.py and buildspec.py, these are just general about deploying your CloudFormation templates. And we have, again, Nginx configurations. This will be used in your system test because you'll be running your system test on these containers. And moving on to the last branch that we have, it's about testing. So the first part here will be evaluating the endpoint, SageMaker endpoint that we have there. And for that, there's a Lambda function that we've written there. It will calculate the root mean squared error. That's again one of the metrics that we use in order to measure the performance of our machine learning model. And once we have got the value for our root mean squared error, that value will then be compared in step functions to the actual threshold that we have configured in on our master pipeline. We have a training job.json. And these are the requirements, or rather what we need to pass through for manifest in order to build a container image.
Basic things like what version of what package you might use might affect things. Somebody did quite an interesting analysis a number of years ago where there's a very popular shallow machine learning framework library called scikit-learn. And just taking the default parameters, so if you don't specify, let's say if you have a tree-based algorithm, how many trees are there to classify the data set? If you just took the default parameters and used different versions of this framework, you got different accuracies, different model performances, different resiliencies, reliances. So if you don't specify that, that could be a huge problem.
Right. And I'd want you to have this GitHub repo open with you, because this has all the steps that we'll be following today as a part of building this MLOps pipeline. So if you go to DevOps Playground, there'll be a repo called as Introduction to MLOps. And under that, you can open the markdown file called steps to follow.
And this code will be available after this as well, as will a recording of this, if you would like to look at it after the fact.
Yes, yeah. Obviously, it will be available on YouTube. Yeah.
Yep. But this code is also, if you'd like to have a look at that.
Yeah, this is a public repository, and yeah, you should be able to access it the same way you're accessing right now. Okay. So about what Sami was saying earlier, the data scientists, when they write code, it would be especially in this format.
This is quite nice, actually. It's got comments. Like, it says what each cell is doing. Sometimes that doesn't have that.
So if you give this file to a software engineer and ask them to deploy a machine learning model, probably you would expect a resignation the other day.
So have a look. Perfect example is it has specified the version of TensorFlow, but it has not specified most of these other aspects. In the development environment, so the SageMaker supplies some pre-built environments. You don't have to create a Anaconda, as it's called, development environment from scratch. It has a version of Pandas that's installed, but we can't see it here. So if you ended up taking it to a different framework or anything else, that would be a problem. And so you need to be quite explicit in specifying things, and that's what in that requirements.txt that we saw earlier, that's what would take care of that.
Right. So this is the data, raw data that you can see on the screen. Education column, you can see that there's a dot between basic 4y high dot school, and these are the cleaning steps that we need to perform in order to get the data in the format that's actually usable. Right. So these are the steps that a data scientist would take in order to clean the data or pre-process the data and then feed it to your machine learning model. And I know that directly looking at this Jupyter notebook without having an introduction would make it feel complicated, but it's not very complicated. It's just you would write functions in a software code, in a software development lifecycle. If you write an application code, it would be in the form of functions, but here it's in the form of cells. Yep. You just directly execute the cell. You don't need to write a function for it, and that would just take care of it. It's an easier way of...
There's two main things that I like about this. The first thing is persistence of memory. So if you do a transformation and then you do a test of the data that came from that transformation, and you're like, actually, no, I'd like to try a different test of that. You don't have to reload the data 3 or 4 times. That can be quite tedious. So after this cell has run, then this cell that depends on the output of that cell, you could run that, change things, run it again, and it would still be working off the same ground truth value. You can also embed graphs and visualizations, which is important for understanding the data set. This notebook is the sort of thing that you would get after a data scientist has completed their experimentation, but it doesn't explain a lot of why they've done what they've done or what they found. So as an example, in the PDays column, and everyone can see that, a lot of the values are 999. That's suspicious. And I remember when I originally looked at this data set, the data set was like continuous or 999. And you might see dates that are like contract ends year 3,999. And like that's not obviously when the contract ends, just that they had to put a number. So a lot of what we do is trying to work out why does the data look like this? Is there something there? So in the case where indicator variable to capture when PDays takes value of 999. The reason that's there is because that has been interpreted to be a specific signal, and that is something that needs to be persisted throughout the data set. By the way, if they change the way that they encode that information, then we need to know about that. The accuracy of the model is likely to get worse. So that's an example of the sort of stuff that goes into behind the scenes. You hope that the data scientist has got good reasons to do these things, and then when this code is taken into production, it will make sense to keep doing these things.
So if you can see here, in the education, previously we had basic.4y, and after doing some cleaning to it, it then looks like in the format that you can see, it's more usable now. And then, like I said, we did split the columns. We did split the data into defining columns for each of the data that we have there. And it increased the columns that we have and changed each of those values, categorical values, into having Boolean values. They're 0s and 1. So if, let's say, if you had your education as education high school, so it would then create a column called as education underscore high school, which would have a Boolean value, 0 or 1. So if it is, if the row has education as high school, it would be as 1 there. And that's again because we need to feed it in this format to the model to train the model.
Yep. As an example, if a new job came along like MLOps engineer, but it wasn't in the data set, so the model's never seen it before, you might shape things in such a way that it doesn't crash when you make a prediction on this job. But because it's unknown to the data set, the prediction might be really poor. It may be very, very important that this model has seen this to make an accurate prediction. What you might do in those circumstances is return no prediction. And that's something that needs to be baked into this. So you may have something that is resilient but doesn't perform the way that you would like it to perform. That stuff is also part of this as well.
Yeah. So this is the way your model would look like. It's a 2-layered model that we have here and one pass-through layer to it. And this is where the data scientist would conclude that this model is performing well. It has a good validation score there, a validation accuracy there, or the accuracy, or different metrics that we need to measure on it. And after this, would say that this is one of the candidate model that we could, have in our store, or maybe come back to later with our testing data to get more, information about the model performance.
So you see that accuracy column, that's on the 90% of data, and that validation accuracy, val_accuracy, that's on the last 10%. So that's the data it hasn't seen each time it's checking how well it's doing. They're quite close, which is good. It means the model is not so much better on the data it's seen multiple times. So you expect it to be about 89% accurate in production. If it's much worse than that, you might activate that break glass thing that Afroz mentioned, that it might say, wait, I've got a validation accuracy of like 50%, and that's very far away from what I'm expecting here. Something is wrong, stop.
Right, so let's now move to this. Okay.
You can see a lot of this isn't data science, and you can see why maybe data scientists may not like a lot of this, but it is very important.
Finally.
Yeah, exactly. Yes. My models have never failed in production because I had never deployed models in production.
Right. So when I said earlier that we'll be deploying resources that will be required for MLOps pipeline, so these are the resources that we'll be deploying using the CloudFormation template that we have here. Firstly, it'll deploy all your Lambda functions, which is your training job launch Lambda. Then we have an ETL launch job Lambda there. We have another 2 Lambdas for monitoring those glue job and for monitoring the SageMaker training job. Then we have a Lambda function for creating your model group. Now, with this model group, what I mean is in Amazon SageMaker, you kind of have one model group defined for your experimentation phase, or for carrying out everything that you need to do with one project, let's say. So every model that you have trained, that you have created, will be registered in this model group. So it acts like, again, a data store for your model, which will have information not just about your models, but about your parameters and about the metrics, about the performance of the model. So we first need to create that model group so that all our models can be registered in that model group, and we can then have a look at it later. Okay, so coming back to the GitHub repo, let me just open it here. So firstly, let's go to the helper commands.sh. And okay, let me just first try to fix this. Okay, this looks cleaner. Right, now try to find and replace the model name here. And you'll replace this model name with either the name of your panda or your name and 2 unique, two numbers, let's say, to make it unique, because this is something that a complete pipeline is dependent on. We'll be creating a role with the same name as your model name, and we'll be having a pipeline created with the same name as your model name. So keep the model name that you can remember. Once you have replaced, just save the file and copy the first set of commands that we have here. So for this, with these commands, we are trying to set the parameters for a complete hands-on exercise, which is setting your AWS account ID, the region that we'll be operating in, the model name, which can then be fed into your MLOps pipeline CloudFormation template. And you can run this directly on your terminal. I hope everyone has done that. Yeah. Okay. Moving to the next step, we'll then set up our environment, and with that, what I mean is just installing all the bash completion steps here, necessary packages on your EC2 instance, and also creating the pipeline bucket. And this will be with the name of MLOps and hyphen your region and your model name, and all the artifacts related to the pipeline, that is the code that we'll be using to deploy your Lambda functions, your step function related code, everything will be in this pipeline. And also the output from your glue job, that is training data set, testing data set, validation data set, and the model metrics, everything will be stored in this bucket that we have here. So just quickly go back to your terminal, and you can copy the code that we have here. It will ask you for the password, and the password should be here, or in my case, the one that I've been messing up with. Okay. Right. So you just enter the same password. It will create the bucket for you. Okay. By that time, you can log in into your AWS console. The link is just at the bottom of the page. And you'll be using the username, the one that you have here.
I think it might be the actual one from there, rather than the changed one.
Yeah.
Should be.
Right. Perfect. And the first step here will be creating a container. Like I said earlier, this is a bring your own container scenario. So we'll first be creating an ECR. Just go to your ECR. Click on create repository, and you'll name it as the one that is provided here, bank marketing hyphen the model name that you have given in the previous commands, helper commands.
This is just making sure that the Docker container containing your model is available from whatever needs to pull it in, and that's the IP address that it's going to use effectively for that, the web address rather.
So if you have the same Docker container, then
Yep.
probably it will cause an issue, and that's the reason we are using unique model names here.
And for those of you who do venture into SageMaker, that's exactly what they use. So you'll see that there's a specific ECR address for the XGBoost that they use on their framework as well.
Right. Once you have created your container, just come back to your terminal and execute the code that we have on step 7. This is just a quick check to know that all the resources that we need in order to create to run our CloudFormation template has been created, which is first having the data bucket, which is already created, and it has the data CSV there. Second one, the MLOps bucket that we have just created using the environment setup code. And thirdly, the ECR repository that we have now created. Everyone, I mean, you should get a check here. If at all there's any error, then do let me know. Okay. Right. After we have done that, we'll then set the parameters that we'll be using in order to create the resources for our MLOps pipeline. So just copy this code. Again, it's under the header create required resources for code pipeline, and step number 1 under that.
With the container registry, I'm getting an error saying I'm not authorized to create the container registry. Do I need to be in a specific AWS region?
Oh, sorry, I forgot to say that. Yes, you need to be on Ireland region for that, which will be EU West 1. So if you're creating your container image, just please go back and check if you have created it in the right region. Okay, sorry for that.
Ireland, EU West
Ireland
1.
region, EU West 1. Yeah.
This is the number one problem, is that when you go to SageMaker or whatever, and you see, where's my node? Oh, I'm not in Ireland yet.
Yeah.
We've all done it.
Every single time when I log into
Every single
AWS. Yeah. So after you have set the parameters for your CloudFormation template, just go back to your IDE and in the same helper commands.sh. Now, like I said earlier, we have replaced the model name with the curly braces with the actual model name that we'll be using. So you need to copy the second set of commands, which starts on line number 30 until line number 34. And this command will upload all your Lambda functions to S3 bucket, the one that we have created right now. And it will replace all the local references that we have in MLOps pipeline.yaml, the CloudFormation template that we have, to the actual S3 bucket references there. And run the same command on your terminal. Now, if you go back to your IDE, you should be able to see another template file here, which is MLOps pipeline output.yaml. It's the same name that we have provided. Okay. And now we'll be creating the CloudFormation stack using the third set of commands. It starts on line number 40 and it goes until line number 43. So copy all those commands and run it on your terminal. You should get the output in the same format, stack ID and then the ARN for your CloudFormation template. And to verify it, you can go to your AWS console and go to CloudFormation. You should be able to see a pipeline with your name on it. I'll wait until I can see everyone's pipeline there.
Get you some more water.
Sorry?
Do you want me to get you some more water?
Yep, I have it. Thank you.
Okay.
Okay, thank you.
Sorry.
You can quickly go into your CloudFormation template and see the resources that it's trying to create there. Like I said earlier, it'll deploy the Lambda functions, training, launch job Lambda, training job monitor Lambda. Your cloud, it'll create the Lambda function for deploying the, creating the package group, model package group. It'll also create MLOps role with the role name that you have provided as the model name. Thank you, Sami, for that.
Sorry, I think I might be a bit behind. So
That's all right.
I just managed to actually successfully validate resource of PY.
Mm-hmm.
What was the next step?
Did you get 3 ticks?
Okay.
Yeah,
Did you get 3 ticks? Great.
it took a struggle, but I got there.
Awesome.
I
Okay.
think my pipeline, my model was case sensitive, so I think I capitalized.
Ah, I see. Right.
Okay. Notice. Okay. So next step would be running this set of commands. You can copy it from the repo. No, for the next one, you need to go back to your IDE and in the helper commands.sh, the one that where we had replaced model name with the actual model name, and copy the second set of commands from line 30 until line 34 and run it on your terminal. And just after that would be running the third set of commands, which starts on line number 40. Yes.
You could run them from the GitHub repo, but Avros has replaced your model name square curly brackets, so it's just easier to run from there.
Yeah.
How's everyone else doing? All good? Great.
Okay. So we'll just wait until the status is changed to create complete, because these are the resources we'll need in order to create the code pipeline. So until we get all the progress to create complete, so again, in the CloudFormation template, it's not just deploying all the Lambda functions, it's also creating the code build projects for us, amongst which the first project will be for building the container image. The second project will be to deploy our models into SageMaker endpoint. And the third project is about creating the workflow for step functions. So the workflow project, image project for creating the container, and deployment project for deploying it into development and production environments. Premium Panda 17, okay. Okay, for this one, I think the name of MLOps role, it's a bit longer actually. I'm not sure how this CloudFormation template belongs to. Premium Panda 17.
Yep.
Okay, so you probably need to go back to the steps and replace your model name to something smaller.
Okay.
Yeah. Okay. Are you good with following the steps from the first step actually?
Pardon me?
Sorry?
This person's name, yep.
Okay.
Are you asking him that question?
Yeah,
Sorry.
yeah, I'm asking him
Are
the
you
question.
okay to go back to the first step and start over?
I
That's probably the best thing, yep.
Yeah.
Sure.
Okay.
Thanks.
And also for the Premium Panda, I guess?
That's him, yeah.
Okay, that's him. All right.
So we need MLOps ops now.
All right, we'll move to the next step. So once we have all the CloudFormation templates into create complete, we'll go back to your AWS console and go to code pipeline. And just click on create pipeline after that. Again, your pipeline name, it needs to be in the format bank marketing pipeline and then hyphen your model name. After that, you can click on existing service role. We'll be using the same role that we have created using the CloudFormation template that we just deployed. Okay, are we good until here?
I'm just waiting for my AWS to load. It seems to
Alrighty.
Okay. So you can just expand the advanced settings after that and click on custom location, and you'll choose the bucket name as the one that you have created, that is MLOps, region name, and then your model name.
So can you say that bit again, sorry?
So the first thing is pipeline name would be bank marketing pipeline, and then your model name. Service role will be existing service role, and here you'll choose the role that you have created. Then you'll expand the advanced settings, click on custom location. This will be the location where you want all the code pipeline artifacts to be stored. The bucket name will be your MLOps pipeline that we have created. Okay. After that, click on next. So this is where we start configuring our MLOps pipeline. And for this, it would be better if you have, both the tabs open side by side, because it will be mostly copying and pasting things. If you miss anything here, the pipeline would fail. And Patrick knows this better. He's been doing that for the entire day today.
I failed a lot of pipelines.
Yeah. Okay. I hope everyone has reached to this stage. Right? Okay. We'll select the source provider here as code commit. As we have seen in the architecture, we'll be looking at the code commit repositories for any change so that our pipeline could be triggered. Here, the repository name will be MLOps, just MLOps. The branch name would be master. Your change detection options will be AWS code pipeline, so that it will keep periodically checking on your code commit repository. Just keep the output artifact format to the default option that we have there, and click on next. Now we are on the build stage, so you can just scroll down on your GitHub repository to go to add build stage. There's a header called as add build stage. Under that, on your AWS console, pick the build provider as AWS code build. Region will be auto-selected to the one that you are on currently, which is Ireland region. And you'll provide the project name. If you click on the project name, I would suggest that you copy the first lines from your MLOps build image, because it will get difficult to find from all the lists that we have here now. And you'll select the model name under that. So that becomes MLOps build image and your model name. And build type will remain as single build. After that, click on next. We'll skip the deploy stage here. And just click on create pipeline after that. This is not the end of it. Yeah. So, okay. So it'll take you through the to the console of your actual pipeline. You can see the steps that you have created. It's just 2 steps. It's not that simple creating the MLOps pipeline. You'll have to click on edit button there. Once you have clicked on edit button, the screen will look similar to this, except for the pipeline name that you have. You'll then firstly edit your source stage there, and also edit the first action that we have added. Going back to your GitHub repository, now you'll start copying the things from your action name, which is model source, because we are right now checking up on the master repository. So we'll name it as model source. Action provider will be code commit, repository name MLOps, branch name will be master. It's already what we had done in our previous step. If you scroll down and come to variable namespace, you can clear that and keep it empty. And your output artifact's name will be model source artifact. Now we'll name it so that in the next stages of our pipeline, we are going to use this as a reference, because we need outputs from each of these stages to feed the information back into the next stage. Once you have entered your model source output as the output artifact name, just click on done. This will be your first action that is configured. After that, you can click on add action again, because we are not just monitoring the model source, we'll need to monitor ETL source, the testing source, and also the data sources that we have.
Sorry, that first one, did you edit the one that was current there?
Yes, yes, that was the current one that I did.
You all right?
Can we pause for a second while?
Yeah,
I do that?
sure.
Sure.
Okay.
How far through are we?
Sorry?
How far through are we?
It's just the start. You can take a seat if you want to.
Yeah, fantastic. Do you want to do
Yes, yes, please.
so? We can probably just go over there. We can move them over there if you want. Do you want to sit down there?
No, not a problem.
Okay. I shall go join my colleagues and come back in a minute.
Just let me know when you want me to continue. Can we have a quick show of hands who have reached until this stage? Okay, great.
So you did the add build stage. So I'm just helping my friend. So we did the create pipeline, added the build image bit.
Okay.
What was the next step after that? Was it hit the edit? Or I don't remember.
So are you on this screen right now, or is it in the configuration stage?
We're on one
Yes.
step. We're on the.
Yeah, you just need to hit edit, I
pipeline.
think, on this. Because you've got build and you've got source. Yeah, so hit edit.
Yeah. So you need to edit the source stage after that,
Yeah, so hit edit.
and it will be then on the screen.
This guy.
And after that, you need to click on this edit button.
Yeah, exactly. Right, and then up here it's model source instead of just capital text. It's now MLOps master. This is now the source stage, yeah. Exactly. So that's a file. That's fine. This is fine. Source variables. You want to delete this one. And then this is cool. Model source output.
Okay. So after that, after you have configured your first source action there, we'll then click on add action. And again, this is the ETL source action. Your action provider will be AWS Code Commit. You can just search directly for that. Select the repository name as MLOps and the branch name as ETL. Change detection options, AWS Code Pipeline.
I'm just curious.
Yeah.
So it says, I don't know much about this. It says recommended is CloudWatch. What's the reason why we're using pipeline instead of the cloud option that's on the options just there?
Sorry. So the action provider that we have here it's actually going to look into the code commit repository. If there are any changes made on the repository, for example, if you have any changes in the data preprocessing code and you push the code to your repository, your pipeline should be triggered automatically.
Okay.
So this is kind of keeping a watch on your repository, and that's been done by AWS code pipeline. That's the change detection option that we are using here.
Okay.
Yeah.
So does CloudWatch do a similar thing? It's just like.
Yeah, so you'll have to add another step of creating that event in order to monitor it.
All right. Thank you.
Yeah. So after you have selected your change detection option, you can name your output artifact as ETL source output, and then click on done. So this is your second source. Now your third source will be the actual data source. So you'll name your action name as data source. The action provider will be Amazon S3. And for this, if you can just quickly look at the screen, there are two S3 options that you'll get there, one under deploy and the other one under source. So right now we are configuring our source stage. So you need to select one under source. And another quick one, the bucket that you'll choose here is the data bucket, not your MLOps bucket. Your S3 object key will be the one that we have here. This is referring to the data set that we'll be using in order to pre-process on. Okay, so this is, let's treat it as your raw data. Okay. And change detection option, again, we'll be using the same code pipeline here. And your output artifact name will be data source output. Okay. Once you have done that, click on done. So you'll have three source actions now: model source, ETL source, data source. We are just left with test source now. So your action name will be test source. Your action provider will be, again, code commit. Repository name, again the same repository, MLOps. And your branch name, this time it will be test. Change detection options will be code pipeline. Output artifact format will remain default. And your output artifact name will be test source output. I'll pause here for a moment until you configure it. Okay. Okay. And then we click on done. So this is configuring your last action for source stage, which is your test source. And you'll click done on your source stage. Right. Now we'll move on to build stage. So you'd want to again click on edit stage button there and click on the edit button for build action. Once you click on that edit button, it should have all this information that we have on the screen right now. So provide the action name as the one on your Git repository, which is build image. The action provider will be AWS code build, and your region will be Europe. It is auto selected there. Now this is what I was referring to earlier. You need to provide your output artifact names in the format that you can actually refer to it in your next stages. So here your input artifact will be model source output. Okay. This is because if you remember, we had a Docker file in your code on the master branch, and this will take the code from there to create your build image. And we'll be using the code build that we had deployed using CloudFormation template. And the name for that will be MLOps, build image, and your model name. So we are until this stage, just to highlight. And clear the variable namespace and choose the output artifact name and change it to build image output. Okay. I hope everyone's here until this stage now, and you'll then click on done button. So this we have done it now. We have edited the build stage. We will then add our new stage, which will be the ETL stage. So click on add stage button, which is under your build stage, and provide the stage name as ETL. Okay, and click on add stage. Then you'll click on add action group. This will bring you to the screen where you need to provide the action name. Your action name will be glue job, as in this stage we'll be configuring it to launch your glue job, and for that it will be using the launch job lambda. So therefore the action provider here will be AWS Lambda. Okay. For this, you'll select the input artifact as ETL source output. So we need the code to be run on AWS Glue, and that code is present on your ETL branch, which we had configured as ETL source output in the output artifacts name. The function name that you choose here will be ETL - launch job, and then your model name. Okay. So keep user parameters the default one, which is blank. Also keep the variable namespace as blank, and the output artifacts also as blank for this one. And then you'll click on done. Now we have configured the ETL stage, which will launch your AWS Glue job. We also need to add another stage so that we can monitor that job, and like I had showed on the architecture, the training job monitor, it needs to feed back the progress on your your ETL job monitor needs to feed back the progress on the ETL job back into the pipeline. So this is the stage where it will do that. So you'll name it as approve ETL. Click on add stage, and again click on add action group under that stage. And you'll provide the action name as approve ETL. The action provider here will be manual approval. And in the comments, you can add any comments that you want. Basically, just you can copy paste it. And click on done. Okay, I think we have. Okay. Okay, sorry for that. Just click on cancel. We'll go back to the stage again. Just click on add stage again, and you need to name it as ETL approval, because this is configured in the training job monitor. So sorry, ETL job monitor. So name it as ETL approval, not as approve ETL. And click on add action group, and basically the same steps, naming it as action name as approve ETL, action provider as manual approval, and the comments that we have here. Once we have the approval for our glue job, we'll then train our model on the data sets that we have created, training, validation, and testing. So again, click on add stage button. This time your stage name will be just train, and you can look at the screen. So basically, if you're following the GitHub repository, whatever is in between add and stage, that's your stage name. So ETL approval or train approval, likewise. So here your stage name will be train, and click on add stage. Under that, again the same thing, add action group. Here your action name will be train model. Your action provider will be AWS Lambda, because we'll be launching the Lambda function, or rather invoking the launch job Lambda. Configure the input out artifact as model source output, because here you'll be using the model.py file in order to launch your training job. Once you have configured the input artifact, you'll then need to provide your function, and it will start with training and launch, and again select the one with your model name on it. So training, launch job, and the model name. Here we need to provide the user parameters to it. Because these user parameters will then be used in the deployment stage that we have for both development deployment and production deployment. So this name is configured in order to create your SageMaker endpoint. So MLOps pipeline, and then the model name that you have provided. Okay. And the output artifact name as model train output. After that, click on done. Now we need to add another stage for getting the result of our SageMaker training job. So sorry for that. Okay, you'll name it as train approval for the stage name, and add another action group there with the name as approve train. Action provider here will be manual approval, and copy the same comments that we have here. And then click on done. Also, don't forget to click on done button on your stages as well. So just do a quick check if at all you have kept it like I had, and click on all the done buttons there, because if at all you click on cancel, or if you go back to some other screen, you'll have to start from scratch. Okay, so now we have train approval as well. This will be the point where we deploy our SageMaker endpoint for in QA or in development stage, let's say. So this stage will be called as deploy dev. Your action name will be build dev deployment, and your action provider will be code build. Now, if you type code build, you'll have all the options here about build, deploy, source. You need to select as just the build one if you just write code there. Yeah. Region remains the same. And input artifacts, since we are deploying it into development stage, and we had seen on our repository, we had all the configurations for creating our SageMaker endpoint on the master branch. And that's what we need to provide here. So our input artifact here will be model source output. And your project name will be MLOps, build deployment, and then your model name. Okay. For this, we need to add environment variable, because this information will be pulled into your CloudFormation template, which will deploy your development endpoint. So you need to provide the environment variable name as stage, the value as dev, and keep the type as plain text, build type as single build, and output artifact as build dev output. Once you have done that, click on done button. You can do a quick check if you want to. So in deploy dev stage, this is the first part where we are creating the CloudFormation template with the configurations that we have in our model source output. That is just feeding the information into the CloudFormation template, making it ready to be deployed. So our next action group here will be to actually deploy this CloudFormation template. So you need to click on add action group, which is present below the action that you have created. So action will just will be in the same line. You need to feed the information into the other stage of it, but it remains the same stage. It's just that there are two different actions that you need to perform in that stage. Yeah. So for this action group, you'll name it as deploy dev model. And like I said, your action provider will be CloudFormation. Region will remain the same, that's Ireland region. And for this, you'll have your input artifact as build dev output. This is the artifact name we had given to our previous action group. Here the action mode will be replace a failed stack. And your stack name will be, you can copy it from here, because if you click there, it won't show up anything because the stack is not yet deployed. We had just configured a previous action group to actually have this stack name created, actually have this CloudFormation template created for us. So replace the model name with the one that you have provided, and that will be your stack name. and your CloudFormation will be deployed with this stack name that we have. After that, in the template, you need to select your artifact name as build dev output. That will be the only one enabled there. And your file name will be deployed model dev.yaml. Next step would be enabling the use configuration file option there. And for that, again, the artifact will be build dev output, and here the file name will be dev config export.json. So the first part is using the YAML file which is already present on your master branch, and the second part is the one that is created via the previous step that we have. You will also need the IAM permissions to be applied to your CloudFormation template, that is to pass the role to your SageMaker role that we'll be creating, so that it can deploy the endpoint and also use that endpoint in order for testing purpose later on. So you need to provide the capability of named IAM. And your role name will be the same with the model name that you have created. And the output artifacts will be deploy dev output. And just click on done after that. So we have configured both the action groups here. You can click on done for deploy dev stage. We'll then move to system test stage. This is your second last stage. I know everyone is urging for that pizza now. So yeah. Okay, so we'll call the stage as system test and add another action group there. You'll name the action as build testing workflow. Here the action provider will be again code build.
Is it, I assume it's the testing one this time, right?
Sorry?
So in code build, there's a build and test one. This is the test.
Yes, it will build the resources that are required in order to deploy the step functions.
Yeah, I mean, it's just like in code, when you search code build there, there's like a test, a build one and a test one. So
Okay, so it's the build one. It's the build one.
The build one.
Yeah. Action provider will be AWS code build under the build. Then we have input artifacts. We'll select the input artifacts as test source output. Your project name will be MLOps and then -build workflow, and sorry, I need to type completely. So MLOps, build workflow, and the model name. And select the build type as single build, and output artifacts as build testing workflow output. You'll then click on done. You'll add another action group here, which is to deploy these, which is to run these step functions. So this will be execute system test. Action provider will be step functions. Input artifacts will be build testing workflow output. It's the one that was configured on your previous action group. And for the state machine ARN, you can copy it directly from here, because again, this is something that's the resource is not yet created, so it won't pop up in the list. You need to replace this with the account ID, and for this you can just right click here, create a duplicate tab, and if you click on the username, you should get the account ID and click on the copy button there. Once you have copied it, just go back and with curly braces you need to replace that to the actual account ID. Also, if you scroll further, you need to replace model name with the curly braces with the actual model name. Once you have done that, just scroll down and come to input type and select it as file path, and the input will be input.json. And here your output artifact name will be system testing output. And then click on done, and also done for the system test. Just one stage to go. Okay, and this stage will be called as deploy PRD, that's deploy prod. Click on add stage, add action group. This action will be called as build prod deployment. Your action provider name will be AWS code build. Region will remain the same. Your input artifact will be model source output. It's the same that we had done for the deployment stage. Your project name will be MLOps build deployment, and again your model name. Even in this stage, you need to add environment variable so that this information could be fed into when you're deploying the CloudFormation stack. So the environment variable name will be stage, value will be PRD. Remember to keep the P capital here, because that's exactly what is configured on your master branch. So if you keep it as smaller p, it won't be able to find the code there. Build type will remain as single build, and output artifact will be build prod output. And then click on done. And there's just one last action group that we need to add here, which is deploy prod model. Here your action provider will be CloudFormation template, and your input artifact will be just the one that you can see here, build prod output, that is from our previous action group. Action mode will be create or update stack. If at all there's a failed stack, we don't want to update it because probably there was some problem there and we would want it to be reviewed first. And the stack name here, since we don't have the stack already created, we'll have to provide this value hard coded here. Now coming down, the template, there you can choose the artifact name as build PRD output, the only one that is enabled. And like we did in deployment stage for dev, we'll provide the file name as deploy model PRD. Your template configuration, use the configuration file, and your artifact name will be build PRD output, and your file name will be PRD config export.json. After that, select the capabilities as capability named IAM. Oh shit. So if you click anywhere out, it'll just take you outside. Wow. Exactly what I needed right now. So I think it answers the question, how long does it take to build a code pipeline? This is when you have all the steps written. So the last step is about adding the output artifact name, and done and just go up and click on save button there. So those are all the steps that we have in our code pipeline. Once we have this pipeline created, I can just take you to a different account and show what it looks like. Right. So once you have all the steps run there, we'll have the CloudFormation templates deployed for your development endpoint, for your production endpoint, and for the step functions. So going to the step functions, it will first go through evaluating your SageMaker hosted model, which is the development endpoint. It will then check for your model quality threshold. Like I said earlier, this threshold is it is configured in our training job JSON. And once we have the threshold, the model below this threshold, it will go and register the model, register the production model in our model registry. That is the model package group with the parameters that we have trained on. And it will move to the next stage about suggesting a baseline. Now, this step will actually run a processing job using your training job data set. And it will try to create a baseline for your data so that whenever new data comes in to your production endpoint, we can do a quick check on what your actual data looks like, the data that you have trained your machine learning model on, and what your production data is. And it will give a variance so that you know whether you need to recreate the steps for creating your data set, or you need to retrain your model on this new data that is popping in. So this variation is very important to know if there's anything going wrong with your model performance, or if anything is going wrong with your data processing steps. And with the SageMaker endpoints, so after you have your training jobs running, you'll probably be able to see that just right here in progress or in completed state once they are done there. And in the inference, if you go to endpoints, this is where you'll be able to see the actual SageMaker endpoints. So the one you can see is we already have a dev endpoint and a production endpoint for this model name, that is Afros19. And dev endpoint is the one that we are using in our system tests, and prod endpoint is the one which we'll be using for baselining and all other purposes. And if you see here, we have the data capture enabled for our prod endpoint. And like I said earlier, this data capture actually stores all the data that we are hitting on the SageMaker endpoint on this S3 repository. So we can go back, have a look at all those JSON files, load those JSON files into a proper CSV, and compare that to the baseline that we have created, or also have a feedback loop so that your model is retained on the data that we are getting as a data capture element here, right? So this feedback loop kind of improves your model performance on the data that is actually coming in on the production environment. If you don't want that, if you want to actually have a look at the data before it goes to model training, you can even do that without having to implement the feedback loop. So that's all the resources that are created using the the MLOps pipeline that we have built here. I know it's quite late right now. I have a few more slides to cover, but before that, let's take a break and have some drinks, pizzas, and then come back. Yeah? Sorry?
10 minutes till pizza.
Okay. Great. Awesome. Sorry for that.
Yeah, any questions?
I'm not sure how many of you got through until this phase, but rest assured you can follow all the steps that we have on GitHub repository. The exact steps, if you replicate it, you should have your model running. We have the model code there, we have the processing code there, the testing code, everything there. You can just set up your code commit repository to have ETL, master, and test branches, and then go through all these steps of creating the code pipeline from scratch. Yeah. So don't worry if you have not created it.
How long is this going to be up? Because I got halfway through and I got a role.
I think it's a question for Patrick, if he's around.
One of the roles.
We normally try and leave the infrastructure up to the end of the day, so probably till like midnight if Patrick remembers to turn it off. If not, some point tomorrow we'll turn it off.
We can try and make sure he doesn't remember, so.
But all this code should just work on an AWS account. Obviously there's a cost to running this stuff in AWS, but you can just do this on anywhere. You should be able to do this on any account.
Yeah. The only benefit on this account is the code commit repository is already set up here. So yeah.
Yeah, so there were other ways of sourcing the code. By far, because it's AWS's thing, code commit is the easiest one to use for this.
Yeah.
It's not necessarily the best code interface, to be honest, but it's the easiest one to integrate with these services.
Someone on
Yep.
YouTube comments asking if you can show the diagram of pipeline just created.
The pipeline diagram, the one
Okay.
that shows the steps.
Yeah, we have that on the repo as well.
Yep.
So if you just
I think the step functions one, I think it's that one.
Oh.
That I want to show.
The step functions one.
Yeah,
Okay.
the one from like a few minutes ago. I think. Is it this one that you think that meaning?
I mean, you can show that.
Sure.
Okay. And the other one, the actual pipeline one, we have it here.
So, so I've got a step functions bit in my pipeline.
Mhm.
Do I have to wait for it to run and then I'll be able to see the same thing?
Yes. Yeah. So it'll approximately take 10 minutes to run your training job and 6 minutes to run your step functions. Yeah. Because in the step functions, like I said, we have a suggest baseline step, which will create a processing job in SageMaker and create that baseline report for us.
So if we essentially created, sorry, go back to that.
Yeah.
If we essentially created that.
Yes, we have created the complete, the green part here is what we have created manually. And this is already configured. And also these artifacts were already created by MLOps pipeline CloudFormation template. So just to give a quick overview, how the baseline report looks like. So if you actually access the baseline report, it will have statistics.json and constraint.json. And it will give you details about each of those parameters there, as in we have an age parameter, the number of columns that are present, that is number of rows that are present in that CSV, how many rows have missing data in it. So if at all on your production endpoint, when you get data, and if you compare it to this baseline, you may find that some of the content or some of the rows are not even getting data in it. And then you would want your model to be retrained because that feature or that column is not at all getting any importance to it.
Yeah.
So will it predict appropriately is the question.
For something like the how many rows are there, that can also be an important data point if you're expecting it to be called upon a certain number of times or expecting it to be pinged once a second or once a minute or something. You could monitor usage of the model to check if anything was wrong with it, as well as the actual features within the data. Please.
So this the number of missing things.
Yep.
So is it like a really strict, like if there's one, then would you want to retrain the model completely, or do you have some acceptance on like? You know?
It depends. If you're expecting there to be missing values, there might be missing values. If you're not expecting there to be any missing values and there suddenly start to become missing values, it could be a concern. But it might be that only one of those columns shows missing values, in which case that might be fine. It might just be that, hey, actually there's no one of this job anymore. That's a possibility for that. But it's very hard to say. What can happen, the main source of missing values, I would say, is the name of the column changed. So you have the original column and doesn't exist anymore. Or you are trying to join 2 or 3 different types of databases and some of them just don't have that data in them, whereas you assumed that it would when you got the original data set.
Clearly that's something you want to address, isn't it?
Yeah, I mean, yes, and it could be an important thing. It could be that, I remember a data set I had, the missing values were when the person had not yet defaulted, and the goal of the model was to detect if they had defaulted. So if it was not missing, that was obviously quite important. But it could just be that there's some other way of interpreting that. What's also important to mention here is you might handle that specific scenario a certain way that means that in the raw data it is missing, but in the process data it isn't. So that might be why it's all zeros, even if the raw data has some missing values. Maybe there's a case you haven't addressed, and it would show up here.
Okay.
There are also ways of doing this graphically, as well as just in a Jupyter notebook that we would look at as well. SageMaker Studio contains some of them.
So you could feed this information directly into QuickSight dashboard,
Yep.
and then either data scientists could have a look at it, or ML engineers, or anyone from business side to know that this particular column is going wrong there, and
Yep.
do we actually need this information?
What's also worth remembering is the origin of this data. It might well be somebody doing data entry, right, when they're signing up someone for a service, and maybe they missed out a field. And so the missing value is actually, everything's been shifted one column down, one row, to one column across. So the missing value might be extremely informative in that way, or it could just be anything else.
So we again come back to the question about how do you choose your MLOps platform? Does it always have to be AWS? No, it does not. It's not always AWS. You might be working on the stack, GCP stack or Azure stack, and probably even on some open source platforms. So what do you need to look at when you're trying to make a decision on your MLOps platform? And the answer to that wouldn't be certain, that exactly these are the things that you need to look for in your MLOps platform, because this completely depends on what model you are choosing, or what problem are you trying to solve. Like I said earlier, if it's a computer vision or NLP model or a regression model, in all these scenarios, what you'd want from your MLOps platform is completely different.
Yeah.
But the generic things that we would want on an MLOps platform is that it should have the capabilities of data gathering and data preparation, or at least a capability that it should be able to integrate with a data engineering tool. For example, Snowflake. You could integrate Snowflake with AWS, have your data engineering done there, copy the code, or rather directly access the code in the Snowflake. Another thing that you would need is some kind of source control, which should be on your MLOps platform, because we are not just trying to maintain the code, but also the model versions, data versions, even the code around data transformations, or your model code and your inference code, or even the third-party code where your model is kind of getting the predictions on. Then comes all the other parts about do we at all need experimentation, or can we do our experimentation on Jupyter notebooks or on Google Colabs and give a candidate model directly.
Yeah. That one's your brackets about, do you want your data scientists to be doing this on this, or do you want them to hand something over to a platform that handles the output that's produced? It would make sense, if you want a holistic vision and to minimize this cadence as described at the beginning, to have something where data scientists could use it. But that's going to be, if you are everything to everyone, the actual solution might be a lot less powerful and a lot less performant. Actually, just going back on that one, in particular, one example I wanted to say was, if you had everything on this slide perfect except for this, and you had this production model that was everything it was business depended on, would it make sense to have one separate MLOps platform and then have that one have its own platform? Or would you want to retrofit that one into your new platform, but that means that it has to handle whatever legacy system this involves, which with Dockerization shouldn't be a problem, but who knows? These are the sorts of considerations that's also important as well. If you want to get your existing infrastructure to fit within this versus make a completely new infrastructure, that's a different question as well. Right. Cost, I think that's also something to put on here, to mention here as well, because you may have something perfect, but it's too expensive to run things on. There's so many features here that may or may not matter to people, and ultimately it's who's using it.
Right, and yeah, so all those things do matter a lot when you're trying to make a decision on your MLOps platform. So there are many more things that you can have a look at. If you want to speak about any of these things, we'll be on the floor after we are done with the session. You can talk to us, we'll try to explain. It's not just the two of us, we have a complete data science team there. Not just these guys, we have extended team, but you can also speak to them. They will be able to answer all your questions. Yes?
All of them, no pressure.
Yeah. Right. So these are just a few that we could name on what are the tools available for MLOps and having almost all the features that we just saw, including the closed source like Data Robot, AWS, and all the clouds that we have. And in open source, we have Airflow, Kubeflow, MLflow, and TensorFlow extended. So we can use all these to kind of configure your MLOps pipeline, right, like we did right now.
Yeah, it's worth adding that even on that closed source side, a lot of the code for that is at least visible and could be open source. It's just that the things that you wrote in CloudFormation are not going to work in GCP, and you shouldn't be surprised that they don't. You could try writing them in Terraform, which is more open source, but it still won't necessarily port immediately across from one cloud to the next. And if you go something like Data Robot, which claims to be omni-cloud SageMaker, then it's even more closed source because although it would work on anything, you have to use that thing now. And it's sort of another abstraction layer on top of everything underneath the hood. Maybe making things simpler, maybe making things more expensive.
Right. So we come to the last question of the session. Why do we actually need MLOps? And the reasons are many that we could list. There are lots of them that we can speak about. But just to give an overview, the blue ones that you can see are the generic ones that also apply to DevOps, like having a code repository, having versions to your code. And it also applies to when you have different teams working for development environment and for production environment. There could be different languages. For example, you want your experimentation to be done in Python, but you want your actual code to be deployed in, let's say, C, because it has performance benefits. So all these needs to be configured, and that's the reason you need MLOps. It could be built into one single pipeline and have all these steps run through. Then we come to the gray parts, which explain about having the importance of features, that is the data columns that we have, and how we need to maintain the consistency on data that we are providing in terms of the training data or in terms of having the transformation rules defined for it. And the orange part that we have here, it's mostly about logging mechanism and the importance of logging mechanism. The interesting ones are when we come to security, that's adversarial attacks and the poisoning attacks. I'll just like to give an example on that one. So if you remember, there was a chatbot which was on Twitter. It was called, I think, Tay. Yeah. And just within few hours of deploying that chatbot, it kind of started abusing people, and it also started showing sympathy towards Hitler. Yeah. And that was because
4chan got a hold of it, if people know what 4chan is, so that's why that happened.
And yeah, that was because as soon as this chatbot was deployed, people started, throwing the data at it in a way that it would misbehave. And that's the example of adversarial data. After you have deployed your model, that's the reason you need to monitor the data that is coming on your production endpoint. Yep. You can't just keep it open, and you would want your metrics to be monitored every time.
There's another example of this, and I don't know if it actually hit production, but it's worth mentioning because it's the sort of thing you could imagine could hit production quite easily. Amazon very famously used some AIs to do screening for job applications based on successful applicants to Amazon, without factoring in that those were mostly white men. So it was hiring mostly white men to an absurd degree. It was like, this is the type of candidate, very accurate, whatever. And if you don't control for that, that's what's going to happen in your data set. And you could imagine a scenario where maybe it was trained on West Coast US Silicon Valley data, and then they're trying to use it in a different country. It just doesn't work because it's not taking into account any of those other things, aside from the bias and other arguments that are worth mentioning there too. So that's also important. There was a funny example of one model that it was a car insurance, I think it was a car insurance premium. If you were born on the Sunday, or if you were born on either the Sunday or the next Monday, your premium was £40 less. So, like if you, let's say I was born, I'm guessing, Sunday 12th October, right? And Monday 13th October, my premium would be £40 less a year. That doesn't make any sense. It was systematic, so there's some trend that it has discovered in the data that doesn't make sense. And fitting too closely to some of those patterns doesn't make sense. And you have to be careful of that sort of stuff. And that stuff can hit production, and if you're not careful about who's using your model and what they're putting into it, and if your model's just unsupervisedly relearning on the same data, this is the sort of stuff that can happen. Being careful of this stuff is important.
Yeah, and this is just the example. Oh, sorry. Yeah. Yeah, I was just about to explain that one. So the example that Sami gave about, so this one is about a crime prevention, right?
Yeah.
Yeah, and the data that we had there, that they had there, was mostly about different colored people, and the model started treating only black people as involving in most of the crimes, whereas that was not the case. It was actually because the data that they had was more inclined towards one set of people.
Yeah, it needs to be balanced.
Yeah, and that's the reason, yeah, you need to balance that data before you can train your model on a specific data. And that's actually the poisoning attack. You already poison your data, which your model is going to be trained on. Yeah.
There's actually quite a funny example. I don't know if it was used for MMOs, it probably was, but the crime hotspot of the US is the LAPD address, because if they don't know where the crime took place, they put their address as the address because they require an address. Yeah. And if you don't control for that, it's going to say something silly like that. Your model might be trained on that and then say the crime's all happening here.
Right. Right. And then we come to the greens that we have here, and it specially describes about model risks and the reproducibility that we need to have. So, for example, when you redeploy a model, if there's a change in your data and you need to go through the complete MLOps pipeline, you have to ensure that your model is consistent with the previous version of it. That's referring to the reproducibility there. And that's also referring to the consistency of models and of having the consistency in the data balance, like I said. So yeah.
One sort of example on this is if you had 1% of your people defaulting on your debt. So you're trying to detect 1% in 100 and say these people are the ones defaulting. The model could get 99% accuracy by saying everybody's not going to default. That's obviously the opposite of what you want. Or it could be really accurate, but say that some of the people who have not defaulted and won't default do default. Both would get you the same accuracy percentage, but you want the one in the second case because it's more likely to be useful for you. You don't want to just tell everyone that everyone is fine. And your second version of your model might do that if you aren't careful. And so you'd find that out very quickly in production because it wouldn't return anyone as ever risking default.
Right. Okay. So coming back to the repository that we have, once your endpoints are deployed, your production endpoint, your development endpoints, and your code pipeline has run successfully until the last stage, we then have one last step there, which is to simulate the load on your production endpoint. And for this, you'll find the code on the GitHub repository. Let's just go directly there. Under utils, you can go to prod load, and you'll just have to change your model name to the one that you have provided. And it will read from the MLOps bucket the testing data set that we had created as a part of our ETL job. And it will pass that data directly onto the SageMaker endpoint. Again, for that SageMaker endpoint, we have given the name here. And it will kind of simulate that load on that endpoint. And once you have that load simulated, you'll be able to see the metrics right here on your SageMaker endpoint. If you click on View Invocation Metrics, and just choose the invocations per instance, the invocations, and the model latency. You can then go to graph metrics, and you'll have your data. It'll show a graph of how the endpoint is performing, where did the auto scaling kick in, and yeah. So you should have all those details there. So it's probably something that you can perform, or to the viewers that are watching on YouTube, you can go through that step once you have your pipeline deployed completely. Right, and okay. And the next stage would be cleaning up the instances. Obviously, when you're deploying a SageMaker endpoint, you wouldn't want it to be running. I did that on my personal instance, and I have not yet used my instance after that. I had to create a new one. Yeah, so please do follow these steps, and also clean up your instance. You'll need to delete your S3 bucket and all the CloudFormation templates that were created as a part of this MLOps pipeline, and your ECR repository as well. Right, and yeah, that's us. Any questions we have for today? Yes?
You mentioned the advantages of MLOps in the sense of consistent poisoning and sort of detect bias. Is it being done automatically and it will step in and correct? Is it something that's being presented nicely in a dashboard for a human to, oh, actually, those decisions aren't being intended?
Afros can go on to explain more, but it could be either. Depends what you want, depends what the platforms supply. You can show those things in graphs and QuickSight dashboards. You can, or there's even in SageMaker Studio, you can actually have these things running. Whether you want someone to automatically do something, or you configure a rule that says actually if this happens, then alert somebody or shut down the model, whatever else is up to you. You could do a basic guard against something like a DDoS attack, where you could say if the invocations goes up to a huge amount, or the utilization goes up to a huge amount, shut down that instance, rather than auto scale grouping it up to a huge instance size to handle the metrics, right? So there are examples like that. Do you want to expand on that?
Yeah, and coming to the poisoning attack, it's completely the responsibility of data scientists and of my ML engineers to see that your data is actually balanced before you're training your model. And that's the reason you have steps about testing the model in actual production environment. Once you've deployed it, you can call it a UAT, where when your business analysts do certain tests in order to check whether the model is performing actually according to the business goals.
Yeah.
And coming to the adversarial attacks, we could have a feedback loop in an automated pipeline, so that when you get new data coming in, it will inform us via either CloudWatch events, trigger an email to the relevant people saying that your model is going way beyond what it was supposed to be.
Yeah.
It's not performing in the way that you wanted. And like Sami said, we could either shut the endpoint down after realizing that invocations are going up, and or you can have a manual step that someone can come in and have a look at it. But probably I would go with this option of having it shut down.
By far the simplest thing that you can do to set up is if you're expecting 90% of the output based on your data set, your original data set, or maybe even some of the production data, you're expecting 90% of it to be a 0 and 10% to return a 1 when you put some input, and you start seeing everything being returned as 0 or everything being returned as 1, that's a problem, right? So you could have an alert for that sort of thing, and this you get some sort of tracking of things. While data scientists like data, piping the data that people serve you back immediately into the model is what leads to problems like TAI. So you would want somebody to validate this to some extent. There's a very funny example that one of my colleagues over there did. It wasn't at the return stage, but it was when you source data from humans, you may deal with problems. It was a classification scheme for a procurement company. And this person got paid something like 1 cent per classification, so they got put this object on the screen or some text on the screen saying this is X, Y, Z, this is scaffolding, this is apples, this is pears, and they just kept typing cheese. So everything was cheese, and they did not put any validation in the data that went into the model, so this model was not improved by this, but also they spent a lot of money giving this person credit for these labels that were actually useless. So much like anything you expose to the internet, if you expose to the internet and you don't have any validations, you can expect the same things you would get with SQL injection and other problems like that. It may be hard to do that for a model, but in terms of you need to validate your user's input, you need to make sure they're not using it in an extreme way, all those sorts of aspects of things.
Cheesy model. Right?
Yeah, exactly. Yeah.
Right. Any more questions? Any questions from the viewers?
Yep.
No?
I think
Okay.
everyone's earned their beer and pizza. Thanks very much everyone for sticking around. Please direct any questions to myself or Afroz.
Yeah.
Thanks.
Thank you.